Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at creating a library for accessing random access files in your application. This was our application at the end of the last video. We have created a program whose task in life is to allow you to open a random access file and save a number of records to that file. Each record is a user-defined type, and the application currently allows you to add a record to the file, amend a record, and display one or all of your records. However, one thing we have not yet handled is the deletion of a record. And in order to facilitate this, we're going to make a minor adjustment to our user-defined type. Currently, our user-defined type, UDT customers, stores a number of fields for each customer. One field we do not have in here yet is an active field. So we're going to add an active field to this user-defined type to allow us to flag individual records as either being active equals true or active equals false. And there is our active field. This will allow us to mark an individual record as no longer being active. In many types of database, this approach is used to mark a record as being non-active, and at some point later, the record can be physically deleted from the database file. This is the approach we're going to take today. So as this field is a long, it will default to being 0, in other words, false. So when we add records, we're going to have to put in a true value to this field. So if we have a look at the populateDB function, this is where we populate the details of a record. And within this prefix block, we're going to add an active equals true. This will allow our newly added records to be recorded as being active. As we have only written a single application to use random access files, the code we have here works fine. However, if you wish to write a number of different applications, each of which will have a different user-defined type, there will be a bonus in writing a library, whose task in life will be to access any random access file. So that's what we're going to be doing today. We're not going to change the application very much in the functional sense, but we are going to create a new library which can be accessed from this application or any other application which needs to access a random access file. So let's go to the beginning of the application and add our library. And this is going to be our library file, pb_randomaccess_lib.include. So now all we have to do is to populate our library. One of the first things we'll want to do in our library is to add a couple of functions, one to open our random access file and one to close it. So we will document these two functions at the beginning of our library file. Open randomdb and close randomdb. Now we're going to have to make some changes to these functions which we created in the last video to allow us to handle any user-defined type. If we look at the existing open randomdb, we'll see in here there's a hard-coded line defining the user-defined type for customers. While this will work fine for this current application, we will in future applications need to access different user-defined types. However, in this function, the user-defined type is only used to determine the length of the string, which is the user-defined type. So we'll quite simply change the parameter list passed to this function to have a length size. So we're going to remove this function from our main code module and put a similar function in our library. So this is the function in our library file. We're passing two parameters now to this function. First of all, the database name, and secondly, the length of the user-defined type. This allows us to open the file as we did before in random mode and pass in the length as the parameter we had coming in to this function. The rest of the function is unchanged. So now that we've changed this function, we'll need to change the call in our main code module. So right at the beginning of our pb main function, we have a call to open the randomdb. it currently only has one parameter, so we're going to have to amend this. So amongst the other changes we're going to make is we're going to create an empty customer global variable based on our user-defined type. This will allow us to set up a completely blank record which we can write to files. This will be useful when we come to the point of wanting to delete records. We're also going to add a local variable called data. This is going to hold the data in our user record. And here is our call to open randomDB with its single parameter. We're going to amend this to add the second parameter. So this will allow us to call the function in our library now that we have the two parameters in place. We'll pass the length of the customer user-defined type. The other thing that would be useful to do is to prepare an empty record. So let's create a new function whose task in life it will be to prep this empty record. And there is our call to our empty record. So let's now go and create this new function. And here is our simple function to prepare an empty record. We're setting the active field to be false, and we're setting all the string fields to be empty length strings, and the balance to be 0. This can be used anytime where we wish to empty out a record. So now that we've completed the first function within our library, let's move over the close random database. This is a simple function with a single parameter, and this one does not need to be changed. So now we can open and close the database file. So the next thing used in our application is a call to the populate database function. So currently, this function is taking two parameters, the database handle and the input file name. So let's go to this function to see if there are any changes we need to make to it. I'm going to add a new local variable called dataOut. This we're going to use to store the record in the user-defined type before sending it to the random access file. And in our put command, we're currently using the user-defined type to send out to the file. I'm going to amend that to use our dataOut variable. We're going to populate dataOut from the user-defined type, and then in the put command, we will output the string. And that's the only change that will be needed within this function. The next function we'll need to make changes to is getDBRecordCount. This is going to be used to count the number of records within our random access file. So we're going to pass the length of our user-defined type as we did before. This will allow us to make this function generic. So if we go to the getDBRecordCount, we're going to remove this function from our main code section and put a function into our library to handle this. And here is our new function in the library taking its two parameters, the DB handle and the length of the user-defined type. And we're using the length parameter to do the division. This will return the number of records in our random access file. So we'll now need to change any call to our getDBRecordCount to add in the extra parameter. And there is our extra parameter, the length of the customer user-defined type. So if we look back at the PB main function, we'll see the next function we'll need to do something with is getDBRecord. So the third parameter, which is currently the user-defined type, will have to change, and we'll change that to return the data in our data variable, as so. Next, we need to populate the customer user-defined type. We can do that using the typeset command, setting the customer user-defined type equal to the contents of our data variable. This allows us to use the existing displayRecord function. And now that we've made that change, we can now remove the getDBRecord function from this code module and add it to our library. And here is our new updated getDBRecord, taking the three parameters, the final parameter being our data string. This is the output parameter, and we're using the existing get command to get the values into strdata. And this, as before, is embedded in a try-catch block. Should any error occur, we will return the value false. So we'll try a quick compile to make sure it compiles cleanly, which it doesn't. We'll need to change the other calls within our application, which are still using the customer user-defined type. this, as before, we'll need to use the data variable. And before we call display record, we'll need to use the typeset command. And that should allow the display record function to work correctly. So there are a number of other calls to get DB record through the rest of the application, so we need to step through each of these and amend it to use the data variable, like so. And we'll also need to add in a default value for active. In this section of the code, we're adding a brand new record, and we want this one to be an active record. So we'll stick active in at the top of our prefix block. So we have now replaced all the calls to get DB record to use the function within our library. So in our library, there is still one last function we'll need to add, and that's save DB record. So let's have a look at the save DB record function. This is a fairly straightforward one, but it is again passing the customer user-defined type. So we'll need to remove this one from this library and change it to pass our data string. So if we look for the code which actually calls save DB record, here is our function call, and as we can see, it's using the user-defined type. So we need to change this to use the data variable, like so. We're populating str data. So we'll need to make the same change anywhere else where we save a database record. So further down where we're adding a brand new record, we're also saving that database record. So we'll make exactly the same change in here, populating the data variable and passing that as the third parameter to this function. So here is our save DB record function within our library, taking its third parameter, data, as a string. And as before, we're using the put command to put that value into a random access file. So if we try a quick compile to make sure we haven't missed anything, and it's functioning fine. So what we've done so far is to create a number of functions within our library which are called from our main code module. We've made some minor changes to the parameters passed to these functions to allow us to make the library quite generic. There's nothing in the library that's specifying a particular user-defined type, as we've changed all of these to pass just the data. And we've changed our main code module to pass these parameters. So, as we said at the beginning of the video, we are updating and adding records to the random access file, but we're not doing anything which would allow us to actually mark a record as inactive. So that's what we will do next. So in here in the PB main function, where we're displaying all records, we're going to put some new code in here. We're going to mark a record as being inactive. If we run the application first, we will see there are our records at the end, 11 records. So we're going to mark record number 6 as being inactive. So we'll put a message to log to say we're deactivating a record. We'll set the record counter at record number 6. So before we do anything else, we'll need to get the record back from the database. And we can do that using our existing function getDBRecord. Now we will populate the user-defined type from the data variable. And we're going to populate that data variable using our empty customer, which we prepared at the beginning of the video. This will ensure all the string fields are wiped, the balance is reset to 0, and the active field is set to false. Now, of course, we need to call the saveDBRecord function to save this updated record back to the database. And we'll display a message to say that record number 6 is now inactive. If we run that now, it will run quite happily, and it will tell us record number 6 is now inactive. However, we'll need positive confirmation that there's actually nothing in record number 6. So our current function to display all records is displaying everything, and it would even display a record if it was inactive. So let's prove that by calling the display all records function once more. And there we can see in all records, record number 6 is appearing, but it has no details in text, and it is showing a 0 balance. So ideally, we'll want to amend our display all records function to allow us to display active or inactive records. So we're going to add an optional second parameter to this display all records function. And at the end here, we're going to display all active records. And our optional parameter, if true, it will display only active records. So here is the header for our display all records function. We will amend this to contain an optional parameter. And there is our optional parameter, active only. We can test this within the body of this function. So once we have got the database record, we can then decide whether to display it to the user or not. So we're going to test the active only, and if the active only is true, we will test the active field in the customer record. And here is our test. If active only is true, then we only want active records. So we're then testing the active flag in the customer record, and if it's true, we will display the full record to the customer. And if active only is not true, then we will display the record regardless. So let's run that once more. And we'll see there is our deactivating record number 6. And in our all active records, number 6 is not showing at all. This is because it's currently set to active equals false. So this allows you within your random access file to set an individual record to be active equals false. This allows some background task, perhaps an overnight run, to go through your random access file and rebuild it, leaving only the records who are active equals true. So in summary, what we've done today is we have created a library to allow you to handle any random access file using user-defined types. Additionally, we've given you a mechanism by which you can display either all records in a random access file or only those which are marked as active equals true. And reading a file, changing its active flag to be false, allows you to save this back to the database. Hopefully you'll find these techniques and code useful in your own applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.